Hi students. I'm making this video about the final exam review. Final exam is like similar to other exams, but it's comprehensive. So you need to know what is scientific method, what is a hypothesis, what is the observation. Like I may give, okay, identify the observation. I may give list of items and ask identify observation. Something like that knowledge you need to know. And some scientists these days, we talk about a lot of Nobel Prize winners, so we should always give a credit to them. So I always like a very important experiment is the Rutherford's gold foil experiment. The Rutherford is the scientist who discovered the atomic nucleus, so it's very important you know those kind of names. And then you need to know what is atomic number. Remember in the periodic table, atomic number is number of protons and then the mass number. And also it's a very good idea you familiar with the periodic table. Periodic table is important and I have several questions. So I have this periodic table here. You can see. The good thing is you can take the periodic table um, to the to your exam, right? You can take the periodic table to your exam. So in periodic table, you need to know. Let me see why you can see the periodic table I have. Yeah. Okay. So in this periodic table, you need to know. Um, you can have the periodic table in the exam, and you know, okay, these you see, the vertical lines we call groups or families because they share similar type of properties, characteristics. And then periodic table horizontal lines we call periods. Why? Because similar properties occur in periodically, so we call them periods. And then periodic table broadly classify into three main groups, which is metals, non-metals, metalloids. Metal, so you can have, you're lucky you can have the periodic table. Make sure your periodic table you mark, okay, these are the metals, these are the metal. Like maybe you can draw a little line so you know, okay, these color all metals. This is non-metal. These are metalloids, so that alleviate little stress from you so you know, okay, I have something. And also you need to know the group names. This is group 1 or alkali metals. If I ask you identify alkali metal, then it should somewhere from here. Group 2 we call alkali earth metals, and then group uh, 8 noble gases, complete octets. Group 7 halogens. So this is the main groups, the classification of periodic table, and we call, you see on the top there is a number 1A, 2A, 1, 2, like that we call these are main group, these two, and these are transition elements. Okay, we go back to the our review. Okay. And then you're familiar with the periodic table, it's very important. And then Bronsted acid, what is a like acid and bases? What is a Bronsted acid? It always give H plus. And then you need to know what are the strong acids. So I have listed, okay, there's a mistake. I'm glad I look at it. It's not HC, it's HCl. This should be HClO4. HClO4. Let me write it down. This is this should be this should be HClO4. This is the strong acid, okay? HClO4. That is the strong acid, hydrochloric acid, perchloric acid, nitric acid, sulfuric acid. So make sure this is H. Perchloric acid is also a strong acid. There are a few other strong acids, but these are the mainly the strong acids. Okay. Okay, and then when I go to the weak bases, like ammonia is a weak base. Oh, another important thing I wanted to show you is the there are when you write a chemical equation, you can write in three ways. what are the three ways when you write the chemical equation? Let me get the sheet. Okay, so when you get a chemical equation, it can be molecular equation, complete ionic, net ionic. So example, let's take simple equation like acid and a base, acid base equation, acid base. Always acid and a base equation, acid has H plus, like it can be HCl, it can be HNO3, it can be sulfuric. Base always has OH. So I'll take a simple one like change the color to the black. So my acid is HCl plus sodium hydroxide. I am getting. How do you predict the products? Always in a chemical reaction, predicting the product HCl, I can separate into H plus and Cl minus, right? H plus and Cl minus can combine form HCl. Sodium hydroxide, I can write Na plus and OH minus. So always H plus goes with the H plus, so one, so H plus positive charge cation goes with the anion of the other compound. This positive charge goes with like that. So then what are the products? You get NaCl plus OH plus H. Two H's, one oxygen. What is that? H2O. This is how you predict the product of any chemical reaction. You always find, okay, what you write the reactants, right? What is the cation and anion in each, and then one cation goes with the anion of the other one. So this we call so, and then it's important we write the states. HCl is a, let me usually we write the state as a subscript. So write HCl aqueous. What is aqueous? Aqueous means you dissolve, you get the concentrated HCl, dissolve in water, sodium hydroxide, aqueous, sodium chloride, aqueous, AQ, okay? And then water, water is a pure water, it's a liquid. So this is the way you write the equation. And then when you have this, I want to show you something else. This is the we call molecular equation. Molecular equation. So now I want to try. So now you see is it balanced? How do you see its balance? Okay, 1H, 1H, two hydrogens. I see two hydrogen in the other side, right? And then I can see sodium hydroxide, one sodium. Oh, like it's balanced already. So then once you know its equation is balanced, you want to write the once you write the complete ionic, then you need to write the molecular equation, then you go to the complete ionic equation. Complete ionic means you see these aqueous states, all the aqueous you separate into its component ions. So let's see HCl, but all the aqueous states you separate into component ions, but if you compound the state is solid, liquid, gas, you don't dissociate. So in this one, you see HCl is aqueous, sodium hydroxide is aqueous, sodium chloride is aqueous, but water is a liquid. You separate HCl into its ions, right? Sodium hydroxide into its ions, and then you separate these HCl, sodium hydroxide, and then sodium chloride you separate into ions because these are aqueous, but you don't separate this what is it water into the water into ionic state because water is a liquid. So if I separate into ions, I can write okay. Oh, sorry. Need to fill my pen. Okay, I get okay. H plus Cl minus plus Na plus plus OH minus give me Na plus Cl minus plus H. You don't separate because it's a liquid. If it is solid, liquid, gas, you don't dissociate. And then you look at this. This is you call complete ionic. Then you have to go to the net ionic. In net ionic equation, you look at the both sides of the equation, see whether there's any common ions. You will learn if you take Gen Chem 1, you will learn in this in detail. And when in the common ions, you try to see these common ions, they're not participating in the reaction, they just make the medium for the reaction to happen. We call these spectator ions. So I try to find the common ions in the both sides of the equation, and I see what is it? Sodium is a common ion, so I try to cancel sodium. I tried Cl, and then these are not. So then I ended up with okay, H plus aqueous OH minus aqueous give me H2O. Okay, so this is the net ionic equation. So this is how you come up from the molecular equation to complete ionic to net ionic equation. If I ask in the exam, what is the net ionic equation for any acid-base reaction? It's gonna be this one, H plus OH minus water. But try to understand this, it's important. So you will learn many things from that. Okay. Okay. So I'm going back to my PowerPoint, no, my thing. Okay. And then can save it. Okay, and then we go to the what is amphoteric means. Like amphoteric is it shows acid and basic properties, and then familiar with the electromagnetic spectrum. Okay, like arranging the waves. Okay, which waves comes? Okay, radio waves have a lower frequency but higher wavelength, and then it comes like order. Like after radio, it comes microwaves, come infrared, comes visible, goes UV, X-ray, gamma rays, and then colors of the visible light. Familiar with that? And then quantum numbers, each subshell, if you for like how many orbitals, what are the main, like principal shell? Principal shell is you call, okay, like one, two, three, like if it is a atom. So if it is, this is your atom and the nucleus, and then it goes like one, two, three, right? So then we call n equals 1, n equals 2, n equals 3. So n is principal shell. So this is like, no, sorry. So the principal shell, and then after principal shell, it goes to the subshell. So the subshells are, you can watch my quantum number video for more. Subshells are S, P, D, L. Example, if n equals 1, you have only one S. So, but each subshell have orbitals. That's what I'm talking here. In S, always has one orbital, P, 3p, D, 5ds, F, 7f's. So you need to know that. And then we go to the mixtures, homogeneous mixture, heterogeneous mixture. If I give you some sample, identify with the homogeneous, heterogeneous. That's important. Identify chemical property, physical property is important too. I'm not asking to define, I may give you, okay, identify with the chemical property. Oh, and then this is important. You need to identify if I give you a compound, whether it's ionic or covalent. That is very, very important. So always keep in mind ionic compound has a metal and a non-metal. Um, Covalent compound always two non-metals. That is the important thing to know. Okay, ionic, metal and a non-metal. Covalent, two non-metals. It's an example if I give you, okay, um, like um, um, yeah, like potassium iodide is an ionic compound. Magnesium sulfate is an ionic compound because it is not two non-metals, but magnesium is a metal, but it's a charge. They're not, um, they completely transfer electrons. So these are all ionic compounds. Covalent, like all non-metals, like if I write N2, NO2, SO2, um, N2O5, ICL. So these are all non-metals, so like that. And then practice like writing formula like copper nitrate. This is how you write copper nitrate. You may wonder why in this copper, sorry, I'm not going to ask write copper nitrate. Sorry, sorry. Okay, okay. So then copper nitrate, right? And then I put 2. Where the 2 comes? 2 comes from copper because copper charge is Cu2 or Cu2 plus. That is the charge of copper ion. Nitrate, it's NO3 minus. Whenever you write chemical formula, you write, okay, metal and this cation and an ion. So which is, you write copper, NO3, and then you exchange the charges. Nitrate charge goes under copper. Copper charge goes under nitrate, but nitrate is 1. Usually you don't put 1, and then the copper charge, not only just you don't write just copper nitrate 2, no, then it's not belong to a whole nitrate, so you write a parenthesis and then you put 2, copper nitrate. So this is how you write the copper nitrate. Okay, so like that, familiar with some compounds that we covered in the class, in the PowerPoint lectures. Prefixes, familiar with the prefixes, scientific notation, writing sig figs, important. Mole calculation. It's another sig figs, rules for assigning significant numbers, familiar with that. And then I have the mole calculation, right? So this mole calculation I have already done it here. How many copper atoms in this many moles of copper and how many moles? So always 1 mole contain Avogadro. So that's what I have written here. 1 mole contain Avogadro's number of atoms, atoms, right? 1 mole contains this many atoms, so then this much. So basically you get the number of moles multiplied by Avogadro's number. And then the part 2 of the second type of question I can ask is how many moles in this much grams. I always say, always to find the moles, given mass, divide by molar mass. So it's here the given mass is 75.77, molar mass is 63. You may want it's 63 point, okay? Yeah. Um, you may wonder why, where did you get it? It's from the periodic table, 63.456. And then I go to the oh, practice drawing Lewis structures and predicting how many lone pairs. So example, um, oh yeah. So example, ammonia, if you have to um, maybe you have to write ammonia and then you draw, okay, nitrogen is a center atom, hydrogen, hydrogen, hydrogen. Tick, tick. Okay. So these are lone pairs, we call lone pairs and bonding pairs. So this is you call lone pair, and then these are bonding. Lone pairs are like by themselves. And then I may ask, okay, draw Lewis structure and identify lone pairs. One lone pair. How many bonding pairs? 3 bonding pairs. And then you need to know the shapes of the molecule. I can let you keep the molecular geometry, electron geometry basic chart. So what is the molecular geometry? If it is, okay, you have a center atom and then 2 bonding groups around it. It's like linear, right? And if you have three bonding groups around it, center atom is a trigonal plane, tetrahedral, like that. You need to know the molecular geometry. So if you take the simple this compound, there are difference between molecular geometry and electron geometry. Electron geometry, you just look at how many basically how many groups, domains around the center atom. So the domain is one, make column, I don't know what it is. Okay, so it's one, two, three, four. Four domains around the center atom. Electron geometry is tetrahedral. But what is the molecular geometry? In molecular geometry, you take, okay, how many bonding pairs, how many lone pairs. And then it is not all, so this is three bonding, one lone pair. It brings me the molecular geometry to, what is it? It's pyramidal, trigonal pyramidal. So so that's why the different in uh, molecular geometry and electron geometry. And then Vesper theory, valence. Vesper theory comes, which is valence. What is Vesper theory? Valence, shell, electron, pair, repulsion theory. So I have given you some compounds. Okay, please practice. You draw by yourself. Identify what is the electron geometry, what is the molecular geometry. Okay. You can try more, but at least these. What is viscosity, resistant to flow, and then basic gas laws. What is the Boyle's law? What is the Charles law? What is the Avogadro? I may not go into detail of how to do the calculation, but at least you need to know the definition. What is a relationship? Boyle's law, pressure, volume, like just study. And also it's a good idea you do the practice problems, you do the calculation, so you familiar. Always just looking at the review will not help, but the idea of the review is you look at the review, you go back to your PowerPoint and you do a whole area. Okay, then you are very confident when you come to the exam. Okay, I hope this was helpful. Thank you very much and good luck for your finals.